hapon. So good morning, everyone. Welcome to our online class for General Chemistry 1. So we are now in Module 4, the electronic configuration. Now let's start with knowing Bohr's atomic model. Now there are a lot of models or atomic models that were released in public because of different researches that come through. Like this one by Dalton. Dalton says that an atom is just an empty sphere. And then Thomson discovered that this is not an empty sphere, but rather it has a negative particles that moves around a cloud of positive. And then Rutherford says that it is not a cloud of positive, rather it is a dense nucleus or dense center where we can find all these positive, and because of these intermolecular forces or these nuclear forces that held the electron on its orbit. And then Chadwick says that it's not only proton that is found in the nucleus, but if there's also a negative, a neutral particle, that is to lessen the what we call this, the attraction of the kanang electrons and the protons. And there's one more there before the quantum model. Actually, this is not just the quantum model. The quantum model looks like more of dots. Na ato si Bohr's atomic model. Nga gihimo niyang pareha na ni planet ang kanang this Bohr pala. This is the planetary model of Bohr. So in Bohr's atomic model, he has a lot of research done, but we will not focus more on that. So in his model, he says that electrons are arranged in an orbit. So dili di sila patakalag pangbutang sa ilahang mga electron dira sa orbit, or dili di ang electron patakalag hansak din ha sa orbit kung ganahan siya. Now there are rules in kanang placing this orbit, and Bohr called it the postulates. Electrons move in a circular orbit around the nucleus just like a planet in its orbit, mo nagitawag sa planetary model, adapting Einstein idea that light particles are quantized. He proposed that each orbit corresponds to a definite number of electrons. As long as the electrons stay in their given orbit, no absorption or emission of energy occurs. The energy of the electron is fixed. So electron always occupy to the lowest energy level. So if an electron occupies the lowest energy level, we call it the ground state. But if an electron jumps to a higher energy level, example, naka-acquire siya og energy, then from first level ni ambak siya sa second energy level, then we call it the excited state. That is just the difference between the two, the ground state and the excited state. So this is what I said. This is the quantum model of an atom. It's more like dots and some other. This is the kanang modified model of Bohr. Kay kung yun ani daw, naka-plenary ra daw ang kanang sana naka-unmute. Please go mute. So mic. Kung ingon ani ra daw ang itsura, it means nga plain lang, planary. Dili siya kanang 3D. So dapat naka 3D daw ang form para na ay space na occupy, kay kung flat lang dili ra kayo, 2D lang siya, dili siya 3D. So that. Then we have quantum mechanical model of an atom. Now the quantum mechanical model of an atom looks like this, but when we do the model, actually we do not draw this. It's more like a number. So the quantum mechanical model of an atom gives us the quantum numbers. The quantum numbers are specific numbers that gives the address, diba? As I've said, in Bohr's atomic model, Bohr said that an electron doesn't just go to an atom's orbit. They are assigned. So, they are assigned through this quantum number. So, muna na-fuse ang Bohr's atomic model. The Bohr's atomic model is kanang ginagamit siya sa quantum number para mas mapadali og visualizing katong diretso mga dot atong lantawon malibog man ta. So mo nang para mas ma-visualize siya, the quantum numbers uses Bohr's atomic model para mas madali ang pagka-visualize sa position sa mga electron. So first number is the principal quantum number. Now do you have with you your periodic table? We will be using that later. So principal quantum number can have values 1, 2, 3, and so on. Pero ang maximum number ani niya kay dili gyud niya siya mabutog 100 but 7. Now go to your periodic table, look into the number of lines per line. Kanang nasa gilid po na naka-indicate dira sa inyong periodic table, di ba na number 1 to 7 nasa pinakagilid. Nakakita mo?
Yes, ma'am.
Yes, ma'am.
So, muna siya ang principal quantum number. The principal quantum number represents the number of period. So, when we say n is equal to 1, it means it is found in line 1 or period 1. We call that row or line as the horizontal line as the period. So, that represents the principal quantum number. N is equal to 1, meaning it is the first period. N is equal to 2 means it's on the second period. N is equal to 3 means it's on the third period. N is equal to 4, that means it's on the fourth period. Now, let's go to the angular quantum number. Now, the angular quantum number is also known as the secondary quantum number or the suborbital. So, kung si principal quantum number, we call it the orbital. The angular quantum number, we call it the suborbital. So, kung ato siyang imaginon, kani si principal quantum number, mauni siya ang balay. Si angular quantum number, mauni ang kwarto. So, the values for angular quantum number is from 0 to n minus 1. So, their values ranges from 0 to n minus 1. Now, from 0 to 3, naa sila'y pangalan. The rest, kay dili, wala naman na sila ga-exist in reality. Wala na sila ngalan, just letter. So, for 0, it stands or it is represented with S or standard. For 1, it is designated as P or the principal. 2 is designated as D, which is diffused. 3 is designated as F, which is the fundamental suborbital. So S, P, D, F. I know you are familiar with this. So if L is equal to 0, it is called the standard or designated as S. If 1 is equal to, if L is equal to 1, then it is called principal or designated as P. If L is equal to 2, then it is called diffused, designated as D. If L is equal to 3, then it is fundamental, designated as F. For 4, 5, 6, 7, we have G, H, I, and J. So, in reality, this subatomic orbitals doesn't really exist. So, there are shapes for those, for these suborbitals. For S, it is a sphere. For P, it looks like a dumbbell. So you can see different shapes of P on different orientation. And for D, duha siya ka dumbbell nga gi-fuse. Pero ang isa pwede pod nga ang sphere ibutang sa center or na siya lingin sa center. That is what we call clover shape. For F, it is a clover shape attached to the center of the dumbbell. So imagine mo siya nga nakay clover gi-attach sa center sa dumbbell. So naniyahang dagway. So to determine the value of L, for example, n minus 1, so the value of L ranges from 0 to n minus 1. N minus 1 is 0. So the value of L is just 1. That is L is equal to 0. And that is S. For n is equal to 2, we have 0 to n minus 1. If n is equal to 2 minus 1, that is 1. So we have two values of L. L is equal to 0 and L is equal to 1. So we have two subatomic orbitals. We have the S and the P. For n again is equal to 1, we have only one subatomic orbital, that is S. For n is equal to 2, we have two subatomic orbital, the 0 and the 1, or the S and the P. For n is equal to 3, we also have 3. When we have 0 to n minus 1, n minus 1 is 3 minus 1, so that is 2. So we have 0, 1, and 2. So we have three subatomic orbitals, S, P, and D. For n is equal to 4, so that is from 0 to 3, since 4 minus 1 is 3. So we have L is equal to 0, L is equal to 1, L is equal to 2, and L equal to 3. That is S, P, D, and F. So what if n is equal to 5? Now, if n is equal to 5, remember that n minus 5 is 4. And going back here, L is equal to 4 is designated as G, which is part of not existing orbital. So, maskin pag niabot na kag n is equal to 5, the maximum L that you can give is 4. Nasabtan ko ato? Any question? Scorpio? Scorpio?
Nasabtan, ma'am.
Okay, walay question. See, next, let's proceed to the next number, the magnetic quantum number. Now, as I've said earlier, we refer the principal quantum number as the balay. We refer the angular quantum number as the quarto, while the magnetic quantum number is the bed, double deck bed. So how many people can occupy in a double deck bed?
Duha, ma'am.
Duha. So every bed na siya duha ka electron nga mabutang. Now, the magnetic quantum number is the number of electrons every particular subatomic orbital could house. So, iyang pwedeng mapapuyo. So, example, the value pala for magnetic quantum number ranges from negative L to 0 to positive L. So, in short, from negative L to positive L, mora na iyang value. So, say for example, for n is equal to 1, di ba we get the L already, L is equal to 0. So, kay 0 man siya, wala siya negative, wala po siya positive. So, we only have one value for the magnetic quantum number, that is 0. So, this means that we only have one degenerate orbital for the S subatomic orbital. It means nga sa kwarto nga S, naa kay isa ka double deck bed. So pila ka buok ang pwedeng makapuyo niya dire sa imuhang S
Duha.
na kwarto, duha ra. Now let's go to n is equal to 2. So for n is equal to 2, natay duha ka value for L. L is equal to 0 and L is equal to 1. For L is equal to 0, nakuha po na natin ito sa task kaganina, we only have one value for magnetic quantum number, that is 0. But for L is equal to 1, we have 3. We have the negative 1, we have the 0, and the positive 1. So how many beds are there?
Tulo, ma'am.
Tulo. So if these are double deck beds, how many electrons does the P subatomic orbital could house?
6, ma'am.
6,
6.
ma'am.
So munang na kay S for 2, P for 6. Now how about for D? So for n is equal to 3, it has 3 rooms. The 0 or S, 1 or P, 2 or D. For L is equal to 0, we only have 1 ml or magnetic quantum number. For L is equal to 1, we have 3. For L is equal to 2, we have how many? We have the -2, -1, 0, +1, and +2. So we have 1, 2, 3, 4, 5 beds or 5 degenerate orbitals. That means for D, we have how many electrons that could sleep there?
10, ma'am.
10.
ma'am.
So how about for N is equal to 4? For N is equal to 4, we already have calculated until D. So let's go to L is equal to 3. Kay si N is equal to 4. Iyahang L taman man kay 3. Ako na lang yung shortcut ha. So the magnetic quantum number starts with -3, -2, -1, 0, +1, +2, and +3. So how many degenerate orbitals or beds are there?
7, ma'am.
7. So if each bed could occupy 2 electrons, how many electrons could be placed in your F or suborbital?
14, ma'am.
14. So it means that in S orbital, there are at most 2 electrons that could be placed in there. For P subatomic orbital, there are at most, so dili kinahanglan 6 gyud. Ang pinakadaghan 6. For D, we have 10. For F, we have 14. Now let's go to electron spin. Now, when we put electrons in each suborbital, dili na siya pwede nga magpariha og dagan. One is going up, one should be going down. Ngano man na. Now, we all know that if two particular charged particles have the same charge, they repel each other. So, to prevent repulsion, so para dili sila magtinuluray away from each other, one should be spinning upward, one should be spinning downward para ma-cancel ang ilahang repulsion. So, muna purpose ana niya. So, for example, in here, N is equal to 1, we have L is equal to 0, ML is equal to 0, then we have 2 pairs. Kay duha man ka electron, di ba kay double deck bed man ni siya. So, duha ka electron. One spinning up, the other is spinning down. We call it one pair of electrons. For N is equal to 2, we have L is equal to 0, ML is equal to 0, then we have one pair. For L is equal to 1, we have 3 beds, so we have 3 pairs. 3 pairs of going up and down. For L is equal to 2, we have 5 beds, so we have 5 pairs also. For L is equal to 3, we have 7 pairs, 7 beds, so we also have a maximum of 7 pairs. So by the way, for this L, kani bitaw siya, balik ko dire, kaning L, kada pair ani gitawag ni siya PX, PY, and PZ. Mga ngalan anang bawat pair ana niya. For kani siya, for D, we just denote it D1 to D5. The same is true with F. F1 to F sub 7. Any question? So to summarize, S has one generate orbital that can hold maximum of 2 electrons. P has 3 degenerate orbital and can hold a maximum of 6 electrons. D has 5 degenerate orbital and can hold a maximum of 10 electrons. F has 7 degenerate orbital and can hold a maximum of 14 electrons. Any question? Any question? Wala? Nasabtan ra? If none, then we will proceed to electronic configuration. So for the electronic configuration, this is the arrangement. So kaning kaganina, kaning atong quantum numbers, mo ni siya ang places or address sa tuang mga electrons. Now, since we know na their address, we know the SPDF, let's go to how they will be arranged. So when we arrange the electrons, we follow different rules. First, we have the Aufbau principle. The word Aufbau is a German for building up. It is also called the building up principle. It states that electrons occupy orbitals in an order of increasing energy level. So first is to occupy the energy level. Now, mali kasagaran nga ginabuhat sa mga teachers sa science is pag makita sila og periodic table, nga na mag akong i-share kadjut lang. Pictures. Mangita sa akong picture sa akong periodic table ha. Agahan na to na akong ibutang. Okay. Share periodic table. Kakita mo sa periodic table?
Yes, ma'am.
Okay. So, di ba, diri nga part, diri sa gilid nga part, kaning left part niya, di ba na number the 1 to 7, which stands for our principal quantum number. Kanang principal quantum number, mo na ilang gi-refer to as energy level, which is sayop. So this is not the first energy level, second energy level, third energy level, fourth energy level, so on and so forth. Dili na siya mao. Now, there is a way to calculate the energy level. Dili ang principal quantum number maoy nagrepresent sa energy level, but the energy level is taken from the sum of the principal quantum number and the angular quantum number. So again, the energy level doesn't represent the principal quantum number only, but the sum of the principal quantum number and the angular quantum number. That is your kanang energy level. Its symbol is NS. So, say for example, if N is equal to 1, then we have 1 L only, that is 0. So 1 plus 0 is 1. Then for 2, we have two values of L, 0 and 1. So 2 plus 0 is 2, 2 plus 1 is 3. 3 has 3 also values of L. We have 0, 1, and 2. So 3 plus 0 is 3, 3 plus 1 is 4, 3 plus 2 is 5. For 4, we also have 4 values. We have 0, 1, 2, and 3. That is why we have 4 plus 0, we have 4. 4 plus 5 is 5. 4 plus 1 is 5. 4 plus 2 is 6. 4 plus 3 is 7. 5 has 4. Kaya wala man ang L is equal to 4 nag-exist. Wala may G. So we only have 0, 1, 2, and 3. So 5 plus 0 is 5. 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3 is 8. Then for 6, we only have 3 na lang. Anong na 3 na lang siya now? If we look into our periodic table, if we go back to our periodic table, kani siya yung mga designated. Kaning duha diri nga column, this is for S. These two columns here also is for kanang P. These columns, 10 columns in the center is for D. And these two rows at the bottom is for F. Na kung lantaw ni mo ang D, nara siya 1, 2, 3, 4. Pero ang F nara siya duha. So mo nang duha ra siya for 4 and for 5. So si 5 na naman siya F, si 6 wala na siya F kay duha ra man na siya pati si 7. Pero si 6 na siya P kay 1 2 3 4 man nakabuok din ha. Si 7 maoy walay D. So going back, so for 6, we only have 3 values, 0, 1, and 2. That is 6 plus 0 is 6, 6 plus 1 is 7, 6 plus 2 is equal to 8. 7 has only 2, 0, and 5. 0 and 1. So we have 0 plus 7 plus 0 is 7, 7 plus 1 is 8. So actually, the maximum number of energy level is 8. Muna siya. Any question? Diyon sa pagkuha ang energy level? Wala? Then let's proceed. So kung imong nabantayan, the energy levels here are not arranged from highest to lowest. We have 1, 2, 3, 3, 4, 5, 4. Nibaba siya 4, 5, 6, 7, 5. 6, 7, 8. Nibalik og 7, ay 6, 7, 8. Nibalik og 7, 8. So, wala siya na-arrange. That's why we have to arrange because according to the Aufbau principle, if you go back here, the building up principle, it states that electrons occupy orbital in an order of increasing energy level. So we have to start at the lowest energy level. So we have to rearrange them in order to have the lowest to the highest energy level. So we start with 1 and ends with 5. So rearrange lang na siya. That's why we have S, 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P. So nauna si 3D before kay 4P. Now let's look at into our periodic table. Yun sa napagka-arrange. So in the periodic table, this is how, ayun ni siya. No. Kadjut lang ha, mangita ko itong naka-SPDF. Okay. Makita ninyo ang periodic table? Now,
Yes, ma'am.
okay, so we have 1s. So 1 means first period and then S. Now, kani si helium, ngano naabot ni siya din nga S samanta ni siya. Kani si helium, kita mo ni bakante dire, dinha na dapat ang balay ni helium. But because helium is a noble gas, managigrupo siya din na sa noble gas. So kung niagi mo og sa 80, niagi mo puno garot si, we call this as squaring the unit. So kani siya si HE diri gid ni siya dapat. So then we have this column is S. These columns here are P's. This one is for D and this one is for F. Kani siya F. So nakabutang na siya. So we have 1S, 2S, 2S, 2P, 3S, 3P, 4S. Kaya di ba dapat fourth, kung ano ni siya, fourth nga kanang sa tawag ani period. Pero pag abot kay D, dili pa siya 4D. Nga naman, mas higher og energy si 4D kaysa kay 4S. So si 4S followed by 3D, then 4P. 5S followed by 4D, then followed by 4P, 5P. 6S, isa ka 5D, I hope you got it. Isa ka 5D, taysa mo follow si 4F, dayon mo balik ta kay 5D pero mag-start na ta kay 2 padulong kang 10. And then we have the 6P. The same is true with 7S. We have 7S, dayon isa ka 6D, dayon we have the 5F, and then go back to 6D, and then we have the 7P. Nanay siya 7P, kaya na-discover naman na siya. We have new elements here. In fact, all of these elements are already named properly. Wala na unknown anin nila. Am I clear? Nasabtan ang arrangement. Again, kaning siya isa sa kaka 5D tay sa mo adto ni 4F, then balik kay 5D. Dayon si 7S mo isa sa kaka 6D tay sa mo adto ni 5F, then mo balik kay 6D padulong kay 7P. I hope it's clear kay hapit ng time. So, now another way to arrange this, kung kapuyan ka mag-add then mag-arrange, so you can just do this. Muna siya naa sa inyong periodic table kani nga order. Maglinya-linya. Then we have the Hans rule. The Hans rule states that when electron occupy degenerate orbital, they just do not pair immediately. So we assign one electron per degenerate orbital. Then if all the degenerate orbital is occupied, then we do the pairing. So in example, si nitrogen. Butangan sa natog tagsa-tagsa din ha, taysa nato siya i-pair. Dili kay diretso ta mag-pairing. So say for example, let's start with 1s. Since si nitrogen has 1, 2, 3, 4, 5, 6, 7 electrons. So since kay 7 yung electron, for the first degenerate orbital, the 1s, we have 2. On the second, we have 2s. We also have 2, kaya wala man ay degenerate kauban kay S ram na siya. Pero pag abot kay P na siya degenerate orbital, so i-distribute sa nimo tagsa-tagsa ang electron dira, dayon taysa ka mag-pairing kung naay sobra. Say for example, what is the atomic number of chlorine? Anyone? Atomic number of chlorine. Look at your periodic table, find chlorine, and look for its atomic number.
17, ma'am.
17, ma'am.
So 17, it means that it has 17 protons, 17 electrons, and 17 neutrons. So let's assume that it has 17 kanang electrons. Kaya wala man siya charged anyway. So let's start with 1s. How many degenerate orbitals are there for S?
2.
For S, how many degenerate orbital? Pila man iyahang magnetic quantum
Isa,
number?
ma'am.
Isa ra. So
Isa.
we have 0. Isa lang. So 17 man na siya. So we put here 1. Isa raman siya. So pwede na itong i-pair agad. So 17 minus 2, we are left with 15. Then, kaya na po may 15, we proceed to the next energy level. Sama nang naka-on. Palihog kog off, ana nag-party-party. Kinsa nang naka-on ugmay. So, still S, we all know that S only have one degenerate orbital, so we can write a pair immediately. So, 15 minus 2, we are left with 13. So, since na po 13 kabuok, we have the next energy level, which is 2p. P has 3 degenerate orbital. The negative 1, this one, the 0, and the positive 1. So, kay naman siya degenerate orbital, ato siyang butangan og tagsa. So, 1, 2, 3. So, minus 3, still, napakay 10. Pwede pa kang mag-pairing. So, we have another 1, 2, 3. So, minus 3 again, you are left with 7. Next, what is next energy level to 2p? We have 3s. 3s has, kay S man siya na siya isa ka degenerate orbital. Kay 7 man na, pwede pa ka makabutang dira og duha. So minus 2, we are left with 5. Next to 3s is 3p. which has 3 degenerate orbital. So kay 5 man na siya, dita pahutak sa atong gibati og pamutang. So 1, 2, 3. Minus 3, we are left with 2. So it means na ay duha ka buok degenerate orbital nga naay pair. Ang isa wala. So this is how we write the electronic configuration. Nasabtan?
Yes, ma'am.
Yes, ma'am.
Yes,
Okay.
ma'am.
That is according to the Hans rule. Now let's go to the pole exclusion principle. The Wolfgang Paul postulated that each electron can be described with a unique set of 4 quantum numbers. Therefore, if 2 electrons occupy the same orbital, such as the 3s orbital, their spins must be paired. Motong ka ganina. One is spinning up, one is spinning down. So kung inyong nabantayan sa akong pagsulat sa whiteboard, ang isa nga akong gibutang, ang ikaduha nga pair, dito na nag-spin down. So, dili sila pareha og spin. That is for their repulsion. Aron dili sila magtinukluray inside the degenerate orbital. So, that is... Now, in writing this into Bohr's atomic model, so if this is the Bohr's atomic model, the spaces or the area, naka-divide na siya into 4. We have the north, the south, the east, and the west, di ba? So, this main direction represents also the subatomic orbital. North is S, dayon, pa-clockwise. So, we have S, P, D, and F. So, imong ibutang diri, itupong na nimo tanan dira ang S, itupong po nimo diri tanan ang P, itupong po na nimo dira tanan ang D, and then itupong nimo tanan ang F. Pag final na, ayaw ang tan butangi sa SPDF sa gilid ha. Ingon ani ang final niya nga dagway. Imaginary lang ni siya nga nakakuan siya dira, nakabutang. Pero pag himo nimo sa imong Bohr's atomic model, wala na sila si S, P, D, and F ibutang. So, automatic na siya. Any question? So this one is, as I have said, the electronic configuration is, or I mean the quantum number is the address of the electron. So say for example, given n is equal to 1, L is equal to 0, ML is equal to 0, and then MS is downward. So since we have 0, we have S. So isa ra gid na iyahang bed, so we have 1S kay duha downward man siya, it means na siya pair na siya upward dira sa gilidaan.